In this video, we shall lay down our equations for ellipse with center HK. In previous videos, we were talking about ellipse with center at the origin. So if we are given an ellipse with center HK and whose major axis has length of 2a and whose minor axis has a length of 2b and the principal axis is horizontal, the standard equation is given by this. It's for our equation whose center is at the origin, h and k are replaced by 0, which is why when our center is at the origin, this is just x squared over a squared plus y squared over b squared is equal to 1. But when our center is hk, this is how our equations in standard form would appear. Again, when our principal axis is horizontal, this is the orientation of our principal axis. You know, sometimes students are confused about how to imagine what is horizontal and what is vertical. So horizontal, it's somewhat like the horizon. When you go out there and you look at where the sky and the ocean meet, okay, let's say, for example, you're in a beachfront, the region where your sky and the sea in front of you will meet, that is what you call your horizon. And it is oriented horizontally. Okay, so what else must we know? Okay, sometimes it is a challenge to figure out if the principal axis is horizontal or vertical. Well, the key there is to look for a squared. A squared is the larger denominator. So between the two, it's a squared which is larger. And if that appears below x, then your principal axis is horizontal. A will help you locate the vertices. So from the center, you add a horizontally, you get to one vertex. You add a or you add negative a. Okay, you know what? In previous videos, we had been saying subtract a. But another way of saying that is add negative a horizontally to your center. That will get you to the other vertex. The endpoints of our minor axis, we shall need b. Okay, so far, we had been sketching the graph or tracing an ellipse using only the vertices and the endpoints of our minor axis. So we shall need b. We shall need b to trace or to locate the endpoints of our minor axis. And with the 4 points available, vertices, endpoints of minor axis, we shall trace an ellipse. Although I'm telling you now right away that in other exercises, we shall need to produce the latus rectum. There's another value there, another value that is not here, but is important in locating our foci, that is c. C can be obtained from this. A squared minus b squared is equal to c. So the square root of that will give us c. How shall we use c? C is helpful in locating for the foci. So if our principal axis is horizontal, we add c and we add negative c to locate horizontally to locate the foci. Let us investigate this equation. Okay, the larger value is 9. This is our a squared. It appears below x, so that means our axis is, or principal axis is horizontal. Okay, this one. A squared is 9. A is 3. B squared is 4. B is 2. What is c? C squared is equal to the difference between this. It's 5. So that means c is the square root of 5. That is approximately 2.24. So we shall sketch this ellipse. It is a challenge to locate the points that will help us trace the ellipse. Okay, so let us do it one by one. So what is our center here? Okay, so this is h, that's 2. K here is negative 1. Okay, so this is our center. Okay, we shall need a to locate your vertices. The value of a is 3. So horizontally, this is our center, 2 and negative 1. Horizontally, we add 3. Okay, 1, 2, 3. And we add negative 3. So negative 1, negative 2, and then negative 3. So that is like 2 plus negative 3. So those now are the two vertices. To locate the endpoints of our minor axis, we need B. Okay, so we shall add B vertically to our center. Okay, so we add 2, 1, and 2. And we add negative 2, negative 1, negative 2. So negative 1 plus negative 2, look at that, that's negative 3. Negative 1 plus 2 is positive 1. So those two are the endpoints of the minor axis. The foci, let's go to the foci. We shall need C. This is approximately 2.24. Again, so coming from the center, we will add horizontally the value of C. Okay, so 2 plus 2.24 is 4.24. Okay, so that is one foci, or one focus. And then from 2, we add the negative of 2.24. 2 minus 2.24 is that one. Again, so far we had been tracing an ellipse using only the vertices and the endpoints of your minor axis. But to produce a more accurate ellipse, we must produce the latus rectum. But we have not been doing that. Maybe in another exercise. Maybe there's an exercise there later on wherein we must produce the latus rectum. But with this information, the vertices and the endpoints of your minor axis, we can now carefully trace our ellipse.